So just so you have a heads up. I wanted to review our first assignment. I finished grading those this morning and just wanted to go over a few things. So let me pull up my answer key here. Okay, here we go. How do I make that big? There. Okay, and I'll post this for you guys as well. Overall, nice job, but there are a few things that I kind of wanted to point out that were common errors. We had the statistical analysis correct. Almost everybody had those or was really close with which statistical analyses to choose. So here I'm looking at the testosterone, the data set number 1, and we used a paired t-test. A few of you chose repeated measures ANOVA, and that's okay. Repeated measures ANOVA will get you the same answer. However, the reason that a paired t-test would be the best is because there's only 2 data points, or there's 2 time points for data collection. Okay, when we write the hypothesis should be like speaking in the future tense, if that makes sense. So what do you plan to see, or what do you hope to see, right? So there will be a significant difference in testosterone levels for blah, 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 okay? The other thing to note, and this is just kind of a, not necessarily like a pet peeve of mine, but something to think about like in all scientific writing from here on out. So like when you take ex-phys and when you take, you know, scientific based classes in grad school or whatever you're going to do, we want to write in third person. So instead of saying, I hypothesize that blah, 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 or we hypothesize that blah, 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 it's better to say the researcher believes there will be a significant difference in testosterone levels, blah, blah, blah. Okay. And then same is true when you do your results statement. So we want to avoid using we, I, stuff like that. So instead you can say there was a significant difference in testosterone levels, blah, 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 instead of I found that this. Okay. So just try and take out the I and we and that sort of thing. Okay. Yeah, and most of you did a nice job. This would have been a good option for a chart. You could also do the averages for pre and post, and a couple people did that as well, and that looked nice to kind of demonstrate the difference with testosterone levels. For data set number 2, single factor ANOVA was the correct answer. So you had 32 subjects, and each subject was in a separate group, right? So they were mutually exclusive. So nobody was in more than one group for this particular test. You did a nice job of talking about shortcomings for the study. So maybe we could have had the subjects, you know, do all the treatments or something along those lines. So a lot of you had some nice ideas about it being dark or light and how that might affect pupil diameter. Again, I know this isn't a topic that's like, you know, we're not experts on this topic. So again, I just wanted you to kind of think about the research design a little bit that way. The best choice for a graph here would be to show the averages, okay? A lot of you wanted to kind of compare like each row, but remember that would be cool if row 13 was one subject and row 14 was one subject, like we saw with testosterone. But that doesn't really make sense with this study because each of these is a different person, right? So there's 32 people and each of these represents a different person. Does that make sense? So that's why like looking at the averages might be a better option there. Let's see. Oh, one other thing to note, a couple of you, and again, these are things that I wouldn't necessarily expect you to know, especially if you haven't taken a research methods class. So if the p-value is 1.48 and then you see this E negative 0.6, look up here at the bar up here. This is what that number actually represents. Okay, so then this is converted into a bunch of zeros. So like basically the -6 means you move the decimal point 6 places to the left. Okay. Again, I wouldn't expect you to know that unless you've taken a statistics or research methods class already. But again, that's the abbreviation for that. So when you want to see the full number, if you just click on this up here on this bar, on the formula bar, it should come up with what that value is. But basically, anytime you see E negative something, it's super negative, or it's super small number, which means that there is a significant difference. It's less than 0.05. Okay. So in order for us to determine whether there is a significant difference between your data, this p-value needs to be less than 0.05. And I think that's explained decently in that like example Excel spreadsheet that you got. But again, if you've already taken a stats class or research methods, that might be something that you were already familiar with. We did a nice job on the third question as well. A few people chose correlation, which will actually give you the same information in terms of the statistics, but the appropriate answer is regression, because we know what the independent variable is, and we know what the dependent variable is. So when we have a set independent and dependent variable, regression is our best choice there. Again, you did a nice job of charting our independent variable and dependent variable, and then, you know, creating a line graph would be kind of our best option there. Again, this one was super low number. So here you can see the p-value down here. I have it highlighted in red. E -16. So again, if, oh shoot, now it doesn't show it up here. So basically there's like 15 zeros before you get a 2. And so it's very, very small number. So there is a significant difference. Any questions on the homework on that one? Okay. And again, I'll make sure that I post that results sheet for you guys so you can kind of look over that. I tried to give you a couple comments when I graded those, but it might be more helpful to kind of look over that answer sheet if you do have questions on that. Okay. Did everyone, have you received your packages? Sarah, Sia?
I haven't checked it today, so
yeah, I haven't checked yet.
So yours both went out. Everybody's who I mailed, they went out on Monday, I don't know, by the afternoon. Okay. And so you should get them. I would think you'll get them today, I would guess, if you haven't already. And people that are caffeine, I saw Val did her caffeine section already. I delivered her package on Monday, so because she lives in Dubuque. But the rest of you who are doing caffeine, if you can do those then, you know, Thursday, because today's Wednesday, if we do those Thursday and get your data posted, that way people can complete those questions on the nervous system. Maybe we can have those, try to get those done by Friday. Again, I'll be flexible with that first due date for that, for the nervous system lab, just because I know we won't have all the data yet. So that would be good if we can do that. But again, those neural questions I'll kind of grade when you guys get those done. Okay, any other questions on the neural lab? I saw a lot of you had already done the some of those reaction time tests. All that stuff seemed fine. Everybody's good there? Mm-hmm. Okay, good. Let's see what else is on my list of things to do. Okay, sensory lab was the next thing I wanted to talk about then. And that is your activity for today. So let me get that pulled up. Again, you need your package in order to do a couple of the activities, but some of them you could do on your own. Okay, so I gave you a Google Doc here so that you can record your results. The vision stuff you can do without your package, so you could do those anytime. But basically you're going to measure your vision, follow the directions on this PDF link here. You can see my screen, right? The Word document, okay. And you're going to use well lit conditions and then also dim. So you can either like dim your computer, or you can put sunglasses on or something like that to make it darker, so that you can do that for the visual acuity. Then you're also going to do this blind spot test, which is here. I don't think there's a way to record anything with that. It's just like, were you able to find your blind spot, basically? Okay. For the hearing, you will need your package, and you're going to need a mallet and tuning fork. You can refer to, there's a video that I have posted on how to use all your equipment. This YouTube video shows you exactly how to do this as well. So you can follow the YouTube video, but you'll do the test on somebody else. Okay, so you're going to test their hearing. So use your mom, your dad, roommate, whoever, I don't care who you're going to use. Okay. I also gave you a cotton ball. So you're going to put a cotton ball in one of their ears and repeat the test. And the sound should be louder in whichever ear you put the cotton ball in, because now you're taking out any like background noise, basically. So they're only getting the sensory information through conduction, through the bone conduction. So that's neat. Again, just general observations here. Were you able to find, were they able to hear, and that sort of thing? Keys for success on getting this one to work. It's got to be really quiet wherever you are. Okay, so just make sure you're in a quiet location when you're doing that test. 2-point discrimination. Again, you also need a friend on this one. This video shows you how to do it, and you'll have like the little round discrimination tool in your packages. Okay, that one's kind of fun. Balance and equilibrium, you can do this one now. So as long as you have a partner or something. So you're gonna have somebody stand, they're gonna do a trial with their eyes open and with their eyes closed, and you're basically you're timing them to see when they sway. And again, it's gonna give us information about our balance and equilibrium centers as it relates to like feedback that we receive from vision. Sobriety test is pretty similar as well. We're looking for how our vestibular system is activated. So again, just a couple questions to go along with this. Nystagmus, so choose maybe like your little brother or someone who doesn't mind like being spun around in like a chair. It's weird. I feel like when I was little, like I liked the silly silo and I liked the, like spinny rides and stuff. And now it's like, oh my God, I'll throw up. That just seems insane. But anyway, you're going to have them sit in like if you have like an office chair or something that can spin, you'll have them sit in that. You'll spin them again, try to not make them throw up. So be careful about who you choose. And when you have them stop, then you want to immediately have them open their eyes and look at you, and you're going to watch for ticks in their eyes, and that's called nystagmus. This is actually the same sensation that we see when people are drunk, when they do like the sobriety test where they have you follow your finger. As you get to the edge of your peripheral vision, your eyes will tick if you're drunk. It's the same thing that you'll see here. So maybe, on Friday night or whatever, if you're out with friends, you can try that test as well to see if they get nystagmus, if their eyes are ticking. Again, you have to, I don't know how drunk you have to be in order to get nystagmus. I guess probably above 0.08 if the cops use it as a sobriety test, I would imagine. I don't know. So anyway, so that's what that is. Okay. Taste, you can do this on your own. I tried to choose things that I thought you would probably have at home. Do the best you can. Okay. So something sweet, just dissolve some sugar with some water. For something salty, just dissolve some salt into some water. For something sour, vinegar or lemon juice will work. I was trying to think of some other things that might work for sour. Those are usually what I use in lab, but again, if you don't have those, be creative and try and find something else sour in your house. For bitter, You can use like tonic water. Again, that's not something that I keep at my house, but that's like the most bitter thing, I think. You can use black coffee, okay, so no creamer, no sugar. Or you can use like the unsweetened baking cocoa. So it comes in like a container that's like a powdered container. So you can use that as well. So basically what you're gonna do is you're gonna take a Q-tip and you're gonna put each of these items on the different sections of your tongue. So the tip of your tongue, the sides, and the posterior section, and see where you sense that sensation the most, if that makes sense, like where on your tongue is the most sensitive, okay? Again, take a drink and wash your mouth out between each of these little taste tests so that it's not like, you know, you're still tasting lemon juice when you go to do the cocoa or whatever. So do take a little minute between each of those. Okay. And then for our assignment for this unit or for this lab, you guys will do presentations. So there's 5 different stations and there's 8 of you in the class. So a couple of you will get a partner, but basically I assign one topic per group or per person. So if there's a certain topic that you're more interested in, if you want to chat those to me, I'll post, I'll give you guys first dibs since you're here today. And then I'll post those after class is over. You know, I'll assign everybody else into a group with you or whatever, right? Again, you'll be able to use all your data from the Google Doc, so your classmates' data, in order to do your presentation. Okay, so just chat at me what you wanted, if you have a preference on the sensory stuff, what topic you want to cover. Any questions on the sensory lab?
So both of these documents are getting turned into the same spot, like the document that we started before and this one?
There are 2 different Google Docs. So I made a Google Doc for every lab. So the nervous system lab has a Google Doc, and I probably should have put them all together, huh? I could have just put everything on one document. Didn't do that though. So each lab has its own document. Is that what you mean, Janae?
No, like turning it in, like submitting this paper. Like there's only one, like it says just neural summary questions. Like that's where you.
So you won't. So you for this lab, for the sensory lab, you won't hand anything in. You'll do the presentation. So you'll rely, yeah. So you'll rely on the class data to get, you know, like let's say you have the eye stuff. Okay, all you're gonna do, you don't have to hand this in. You need to post the data so your classmates have the stuff for 2-point discrimination and that sort of thing. But you'll just do a presentation. So you'll follow the guidelines down here and just cover your topic.
Okay.
That's what you mean, right?
Yeah.
Okay. Yep. So we'll do those presentations on Monday morning during Zoom. And if you guys can't make it, then just, you know, email them to me ahead of time. And there's a rubric down here, what I'll be looking for each of those.
How long should that be?
I don't think I have a time limit.
Okay.
But some of you will need to do a statistical analysis. So like the eyesight one, for example, you'll want to do statistical analysis here. This is a paired t-test. Hearing is pretty qualitative, so you'll just talk about this. There's no statistics to do for that one. 2-point discrimination, you'll use repeated measures ANOVA because you've got 1, 2, 3, 4, 5 different measurements per person. Okay. Balance and equilibrium, you can do a t-test for the Romberg's test. Again, that'd be a paired t-test. And taste, I can't remember how I set that up on the Google Doc. I think you could probably do a repeated measures ANOVA with that as well. We'll have, that one's kind of a hard one to analyze. But yeah, you could do a repeated measures and look at how many people chose sweet on the tip of your tongue and that sort of thing. Something like that would work. So yeah, so basically you'll describe your sense. And what I would do is use the information from the sensory lecture that you're going to watch tomorrow for your sense. And that's great background information to describe the anatomy and physiology. Talk about how you did the experiment, results, use the class data and statistics when appropriate, and then discuss why you found what you found or what you had expected to find. And then one question about you can choose a disease or a condition that affects your sense to discuss here. And then have some scholarly sources at the end of your presentation. Okay. Any other questions on sensory? Everybody's okay? All right. Okay. So let me see, check that off my list. Okay. Did you guys have a chance to watch the nervous system lecture? Yes, I see some people shaking their heads. Okay, so the activity that I wanted to do today is basically review the resting membrane potential and the components associated with that. So, anybody on like a iPad? You guys are all on standard computers? Okay. Well, is there a way for one of you to share a whiteboard? Because again, I don't want to like do this for you. I want you to like work together and do it. So if you go down to share screen, one of you can choose whiteboard. Should be like at the top. Okay, so basically what I want you to do is set up a cell. So set up a circle to start. And then I want you guys to talk about and add into your image here all the components that are important in order for us to maintain that resting membrane potential that we talked about in the nervous system. Okay, so again, inside the cell is negative 70 millivolts. And so basically in order for us to maintain that, there were like a bunch of different things that needed to happen. Do you remember what I'm talking about? Yes, a little bit. So get out your notes if you can for that section. It's neural, whatever, it was like lecture 2. I don't know what slide numbers.
So you have to have like a low concentration of sodium inside and high outside, right?
And then you have to have a high concentration of potassium outside and then a little inside.
Do you have a touch screen, Jess? Or are you the one with the...
Yeah, mine's a touch screen.
Nice.
I think is it high potassium inside and low outside? And then
Yeah.
it's like switched for the sodium.
Yeah.
Do you remember the amount?
I think on the
5?
inside, yeah, you got it.
A 5 is extracellular and 150 is intracellular for potassium.
And then for sodium, it's 15 inside and 145 outside.
Go outside, dude. Door's freaking open and he's like sitting here growling beside me.
All right, so do you have to put like the leaky channels and the gated channels?
Yes. Do it.
Okay, well, I have to look up a cute little picture.
The leak channels, we just put like 2 lines in the circle, like on the perimeter, like the outside of the circle.
Like an open door.
Yeah.
Like, it just go all the way around?
No, I just just on the side, just do,
It's like perpendicular to the.
no, like, I don't know how to explain it. Like,
I think like the 2 lines are perpendicular to the cell membrane.
How do I?
yeah, like they go over this, like the circle's this way. and you're gonna
Wait,
put
I
a line
can't see you. Hold
down.
on. Okay, what?
Okay, so you have the circle like this, and you just gonna
Yep.
put lines like that.
And there's another one to make like a little.
Yeah.
Yeah.
And then the gated channels, like we just like put little humps on there, but on like a different spot.
Is that inside the circle?
Outside.
Outside.
And then another little hump.
Next to it out here?
Yeah.
Mhm.
Can more than one person edit this at a time?
I don't think so.
I have no idea.
Yeah, I don't think so.
Well, that would be cool if you could. Oops.
Do we need to like write how like the potassium, like the arrow with the potassium going in?
Yes. Yep, so leaky channels and your gated channels, which allow which molecules to do what.
So the gated are letting the sodium out.
Which one is letting it out?
The gated, so the hump ones, the ones that you jump to, big humps. And then they kind of bring potassium in.
Oh, the same one does?
Mm-hmm.
What else do you know about these gated channels? There's 2 other important things to note.
Is it that they're sending 3 out and bringing 2 in so it stays negative?
Yep. Yep.
Okay.
So 3 sodiums go out, 2 potassiums come in.
And then for the leaky channels, that's when the potassium is going out. And like the dash ones. And then the sodium is going in. I didn't catch in the lecture if it had like a specific amount for that one.
Yep. So the leaky channel is more permeable to potassium. So just imagine that the potassium molecules are smaller, so we can fit more potassium molecules through that gate versus sodium. Those molecules are bigger, so they're harder to get in. So we can move 50 to 100 potassiums for every 1 sodium we move in. Yes. One other thing with your gated channel, again, notice that we're moving sodium and potassium against their concentration gradient. So what type of movement is that? Is it passive diffusion,
Active?
Active.
active transport? Yep. So what does that require?
ATP.
Yep. So maybe put like a little ATP down by your humps. Okay. So these are the kind of like the background information now. One thing to note also, and again, those of you who've taken chemistry know probably more about this than I do, sodium and potassium are both positively charged molecules. Yes? So how is it possible that the inside of the cell is negative 70?
Is it just that the outside is more positive? Like there's just like a lot of positive on the outside of the cell?
So think about both of these channels and look at these like they're like a bank account, right? So if the inside of your cell is your bank account, and I spend 50 to 100 potassium dollars, and I only gained one sodium dollar with my leaky channel, that's not good. I'm not great at finance, but that's not good. Okay, you spent more than you brought in. Okay, same is true with your active transport gate. I'm spending 3 sodiums, or getting out 3 sodiums, but only bringing in 2 potassiums. Okay, so again, that's creating a negative net of 1. Okay, so it's those two things together which allows us to get this negative 70. So basically I'm creating this negative balance inside, even though I've only moved positive molecules this whole time. Does that make sense? Okay. So now let's do everybody okay with that? Everybody feels comfortable with that? Let's do a new one. Let's get a new picture. Do a new share. Anybody else have a touch screen? Sorry, Jess, you're up again.
Okay.
So show me the movement of molecules for depolarization and repolarization. And how's that related to that resting membrane potential? So I would start by drawing your circle, and then put, you had a 150K inside, and you had 150 sodium outside, or 145, whatever. And then you had 5K on the outside and 15 sodium inside. Okay. So what's depolarization?
It increases the charge.
It increases the charge. Which molecule is going to move? So we need to go from negative 70 inside to like plus 30, basically.
Put one of these, the Na sodium in there.
Yeah. Look at the difference in their concentrations. If I open a gate for that sodium can go through, he's going to want to go inside because there's less of him inside. He's going to want to go down his gradient. Okay. So basically for depolarization, all I have to do is open this gate that sodium can move through, and then sodium's going to rush into that cell. Because it's a positive molecule, then you're going to see that increase in charge. Okay. And that's excitatory. That's good. That's how that cell is excited. How do I do repolarization then?
Take the potassium inside and then have it leave.
Yep. So we have a separate little channel that will allow potassium to move. And again, look at your concentrations here. You have a lot of potassium inside and just a little outside. So if I open a gate for potassium, he's going to want to flow out, which is going to decrease that charge. And that's what repolarization is. It helps us to get back to like regular resting, basically. Kind of weird, I think. You know, you think about, well, if I move sodium in, what shouldn't I move sodium back out? You know, why isn't there ever like an imbalance within the cell? But those leaky channels and that active transport that we talked about when the cell was at rest will kick into gear to help us get back to normal also once the process is over. Okay, questions on depolarization or repolarization? Everybody's okay with those? Okay. Tell me then about the absolute and relative refractory periods. That's my last thing.
The absolute refractory period is when the sodium gates are closed, so you can't have a new action potential because you can't like depolarize.
Correct.
And then for a relative refractory period, if the signal is strong enough, it can elicit an action potential, even if the cell isn't fully recovered or like back to its resting state.
Good. Yeah, very good. Okay. Any questions on that lecture in particular? Everybody feels good? Okay. So today you do have a quiz. I think I opened it at 10 a.m. I can open it sooner if you want. If you wanted to start at 9:30, I can. Because if you guys are, I'll open it at 9:30. It's open like 9:30 till like, I don't know, 6 tonight or something like that. You can see how the times that it's open, right?
Yeah, it's open till 8.
Oh, till 8 p.m. Okay. So so that quiz is 21 points. So it's like probably 20 minutes or so, I would guess. And then you have another quiz tomorrow. That quiz is open. I think like I opened it like 6 a.m. till 1 p.m. or something like that. And then we'll plan to see you on Friday. I'll explain the digestive lab, and then you'll have the digestive lecture to watch on your own on Friday. So it'll be a short session on Friday. So any questions? Everybody's good? Okay. Oops, I don't want to share my screen. That's what I want to do. So I'll get this posted so you can have this to look back on. Otherwise, have a great day. Let me know if you guys do have questions, and I will hope to see you on Friday.
Thank you. Bye.
Thank you.
Bye.
Adios.
Bye.